Hello and welcome to this very first video about my passion project VeriBIM-KG. In this video I will share my journey to bring an ambitious vision to life. It's all about uh, combining three great IT technologies: building information modeling, graph knowledge graph databases, and artificial intelligence. So whether you are a developer or construction professional or just someone who is curious how those three technologies can be combined together to bring a better enhanced project assurance, this video is for you. To implement the vision, which I have explained in detail in nedev.digital blog site, and I will show you in a minute a screenshot of it. There are multiple technical solutions, multiple technical approaches, probably not endless, but a very vast amount of technologies that can be used. I have selected the technologies based on my knowledge, my experience, and my preferences. So in this video, I will share my project development for VeriBIM-KG, and it is an enthusiasm-funded, open source, and open-minded approach. I am using also a co-pilot assistant to help me do the coding, which let me focusing on the principles, focusing on the concept and architecture of the system without being bogged down to the little technical details. In this video, I will not show you a very new, complete, flashing user interface application. No, it will be just the first step, the very first steady step for the future development. However, I will demonstrate a system backbone that you can use it as a blueprint to if you like to support this project, or whether you want to use this blueprint for another development using the same principles and possibly using the same techniques. So without any further introduction, please let me share my screen and I will switch to a more detailed explanation about the architecture as well as a live demonstration. So just please hold for a second to switch to the screen sharing. And as I explained it, it is the phase one of the project, and it is about a case study about my own development and my approach to the system. Okay, to explain the whole system that from technical perspective, it is a microservices. It will be using microservices within Docker containers. And the whole application is split into three main pipelines. One of them is to convert documentation to knowledge graph, and you can see the in the middle the top two boxes, doc2kg front end and doc2kg back end. So these are the two parts of the application, one of them which is running on the client side, one which is running on the server side. The second pipeline is converting a BIM model from IFC files to knowledge graphs and using the same data sources to be able to combine the same data. And the third streamline or pipeline is the rack application. This will be the main consumer where the end user can actually be able to interact in a contextual and into an intelligent way with the model, with the documentation to ask questions being augmented by the knowledge graph. So the whole architecture for the Docker containers would give a good flexibility and modularity of the system to allow each element to be developed and also tested and performing in its own environment. However, in order to keep everything secure, all of this should work in a private local area network or LAN, and there will be just one single entry point, which is shown here on the left hand side on your screen, which is the base application, which is effectively a reverse proxy application, which will be using a REST approach, RESTful path routing to access the containers inside the application. So using in future phases, we'll focus on security and on the implementation, on the deployment of the system. However, at the moment, I will keep it open. It is just predetermined that this will how will be developed at later stages. And all the backend containers will access a common data sources. MongoDB will be used for some metadata. MinIO will be used for a file repository, whether it is documentation or models. And the main bit is the Neo4j knowledge graph database to create the knowledge graph. So this is in essence the main bit that will be is the heart of the whole system. So without any more on that layout, what I would like to do now is switch to some more materials that I want to show you. So first of all, this is my blog site on nedev.digital, where you can see the vision explained in details. And as well, there are some more articles which cover more technical vision, how to do the application or how to do an application. As I mentioned, there may be various technology that can use to implement the same vision. My implementation of this vision is in GitHub. It is a publicly available repository. So if you search for Vasil Nedev /VeriBIM-KG, you can get access to the project. And as I mentioned, at the moment, it is released to phase 1, which is explained in more detail inside the VeriBIM-KG in the README file in the repository. I will not go through the details because this is what I have just explained on the previous slide, the main layout. However, if you go to the phase 1 release, it explains what has been achieved to date. And to date, I have done only the setup, but it is a fundamental part of the application development, because this will dictate how the future development will be done. I will not go through the details in reading the actual documentation, because what I would like to do is to go to a live presentation on how, if anybody wants to use this repository on your own computer, or whether you want to use part of the code as a blueprint, whichever way you like, or to fork the a repository for your future development. So let me move to next part of my presentation, which will be showing the code inside Visual Code Editor. So there are only two prerequisites to use the application. It is to use a code editor. I would recommend strongly Visual Code Studio, but I don't see any reason why not to work with any other system. And Docker, I'm using Docker Desktop on Windows on this presentation. However, I'm having another development system. I'm developing on Linux. So if you have other Docker setup, it should work perfectly well with it. I haven't tried Mac, but I don't see any good reason why the same setup not working in the same way, as I will demonstrate today. So let's start with first briefly explaining the repository folders. Each part of the application, each microservices has got its own folder, and the main folder has got a number of Docker Compose manifests. I have splitted the whole manifest into 4 separate parts. It is just to be easier to maintain. Otherwise, it may end up into a very long, very big compose file, and also have annotated, so you can find out easily each part. In my implementation, I also have included Redis. So for the developers, I will not explain what Redis is for, but yeah, it needs some more components. As well, there is some dev setup. What you may notice here as well that I have exposed the ports as well of all the data sources. So this is only for the development purposes. I don't expect during the production these ports to be exposed outside of the private network. However, I find this very, very useful during the development to be able to see the data sources as well. So please feel free to review, to check the compose files, manifests about Docker. I will not go through detail of each of those files. I think they are very much self-explanatory if you know how the Docker manifest works. Will not cover them any further. The next thing that I want to point your attention to is I have created an installation dependency scripts. One of them is which will work in Linux, and one of them which will work in Windows. I have used both of them, so both of them were working for me. If they are not working well on your machine, please let me know. There may be some little errors of them. I'm not very much excited on those two script files, because the only thing that they do is, I will show you in a second, it is just to run a Docker run command, which will install each of the containers folders, each of those folders into user source app, and will run an npm install. So it is just to install all of the packages. I have already run this on my system, but if you do a fresh clone of the repository, you will not have the node modules folders in your folders. So this is what all the installation scripts are doing. Also, something that I should have started with for people who are not very familiar with the Visual Code Studio or may using other systems, how to clone the system. It's not a very big deal indeed, but what can do is just get a new window, and the recommended way will be, if going through clone a repository option on the new window, and yeah, obviously when you are in the correct repository, you can get the link straight from the GitHub repository. So this is how to get the repository. Just I clone the repository, and you should be able to see this picture. Then do the installation in order to get all the node modules to each of those folders, and then at this stage should be ready to go on Docker to run the containers. So let's move to Docker now. As you can see, nothing is running, nothing much special on the Docker itself, just vanilla installation from their website. Whether it is where you're doing this on Linux or on Windows, there is nothing special for the Docker itself. But I already have moved to the project folder. If you can see my terminal there, and the next thing to do is I have already run some of the commands, so it will be easier for me to just scroll. But for testing of the installations, what I will do is I will run the docker compose F option, compose dev base YAML, and also compose dev doc2kg YAML. This should let me run the base application, as well as some of the very first pipeline, which is document to knowledge graph pipeline. So start this and just watch the Docker container spinning, and once they are up and running, should be able to see something like this. It's very easier to use the visual interface of the Docker desktop. Using Windows, you may prefer to use Docker logs to monitor what's happening in the containers, but for this presentation, I will stay with the Docker desktop application. So let's see whether everything has been set up and running then. Nothing too difficult, just need to point to localhost. One notice to make here is that I'm using port 80 for all of the services. And that is the benefit of using the microservices, because it is just one application running in each container. So I don't see a reason why not to use port 80 as the default HTTP port, and also the base application is using port 80. So I don't need to specify any ports or anything, just the local host address. And what should happen is, in fact, it is good because it just shows me that my proxy server is up and running, although it says that there is an internal server error. The error, I will show you in a minute what it is and why it shows at this stage. Let's investigate actually first this. So there is no surprise. So if you go to the base app and click on it, and probably don't need anymore for the time being this terminal. So it says that must provide a proper URL as target, and it is simply because my base application is a very, very minimum setup, and at the moment it doesn't have any default route. And this is what's happened, because I'm saying, give me something, give me the default route, but there is no default route, and it just say, oh no, I can't show you anything, there is an internal error. So no much of a panic on this, but there is one route that I have created on the proxy server just for testing of the actual proxy server. So I go to health route. If I spell it correctly, it might. Okay, so this at least gives something which says, okay, it's running, there is some uptime, some more little technical data, but this just indicates that the proxy server or the base app is up and running. And let's see if it can go to the .kg front-end application. So it is spending some time. It is okay. I will explain in a minute the application, but because when I make a call, it goes and it triggers starting a process. So it may take a few seconds before you can see something like this. And this is the very minimum setup. Nothing. I haven't developed it. What it says is that, okay, this is my development to knowledge graph stack. I got the front end container ready for development. I got the backend container ready for development, and I also have got the data services ready as well. So let me, and I have links to the other two pipelines, which at the moment are not going to work because I haven't started their YAMLs. If you remember, I will do this later so you can see them showing exactly the same setup, because at the moment there is nothing really developed yet. Okay, the other thing that I wanted to demonstrate is the access to the services. As I pointed out in the YAML files, I have set it up the default ports as well to be exposed to the local host, so you should be able to get access to Neo4j. Okay. See, I go to host on 7.74. Okay, so it just shows some connection to the Neo4j container. I will not explain this in this video yet, because this will be subject to another presentations about the graph databases, etc. So just wanted to show. Yeah, this time it worked. Click the. So this is the main IO. Not sure why this Neo4j didn't work in first try. Okay, yeah, no problems. But yeah, I'm using the default ports. So okay, I don't remember which. There was some default users and passwords for the MongoDB, but sure it will be working as well. So this is what you should see if you're running just those two stacks. For development purposes, what I also want to demonstrate and to go through is to each of these applications with a little bit of a brief explanation of the code itself inside the repository. So I will go back to my Visual Code Studio and we'll start with the base application, which, as I said, is just a reverse proxy, express reverse proxy. So let's start with the package JSON manifest. Nothing too much special. The only note that I want to make is that it is using the NoteMon legacy watch. What I found out is that if using the Note watch facility, it doesn't work on Docker and Windows. So this is just a note. If you are using Linux or probably Mac, you can prefer not installing this dependency, but going straight to the Note watch option. But if you are using Windows, this should work for any setup. The only thing is that it is a legacy watch, no polling or polling option, whatever is the difference. Can check the documentation, but just installing one extra package on top of the usual Express. Also, as I said, this is a very open system at the moment for development purposes. So it's supposed to be running on your local machines. So I'm using Cores, so not bothered about any cross-origin requests, etc. They will be dealt in a future phases when we'll deal specifically with the security and the deployment of the application, getting ready for production. So this is the manifest, and the sources is very empty folder, just one index.js. Not a big, nothing really very too much excited from, just got an Express server. As I said, enable cores to avoid if you are having some local arrangements about not opening the local host but something else, and also how the system works internally. But one thing to point your attention is that how simple the reverse proxy works. It basically, it says these are my routes, and they're just going to these URLs, which are the Docker service names. So if you open the compose, the Docker compose manifest, you will see that this is the name of the service that I want to run. And that's it. And it is on the port 80, so nice and simple and straightforward. There was, from developer's point of view, there was some time that I spent actually to make the WebSocket working, and I have made some notes here, but at the moment, because I'm using Vite for the front-end applications, and it relays on the WebSockets to do the live updates. So everything should be working. I will show this in a minute, actually. And here is the only route that I have developed so far is just this help route to just for the testing purposes, general. And yes, here is all the requests should go to the proxy. That's why at the moment it just says there is no default. It is expecting specific path to be given. So this is the index.js for the reverse proxy. One thing that I want to demonstrate as well is about this NoteMon that it is actually monitoring live the change of the code. And what I would like to do is I have a router here. I just want to see where it will be. Let's create another route here, for example. So if we do app dot, we got a get requests, and if I got something like test. So actually, this is also demonstrating. I have mentioned this in the introduction that I'm using an AI-enabled coding, but if you notice, I haven't typed it, and it is just coming. It's coming from the Copilot agent. We just make a little note on this, and I want to show you where it comes from. So if you see this GitHub Copilot installation, so if using the Visual Code Studio, I would encourage installing those two, and that will save you a lot of typing. But the main thing that I wanted to demonstrate here actually is that if I save this, so now I should have a test on my proxy. I should have some test route. Let's see, message test endpoint is working. Okay, so it is this one. So NoteMon is doing its job. It is just watching my source source database. Sorry, not database, my source code, and just restarting the server every time and making changes. So if I remove this, do another save, and just refresh this, it will say, oops, there is nothing there. This doesn't send any data. Actually, it took some time to recognize, to restart, but this was what I was expecting, that the internal server error will come, saying that effectively, because it can't find any route, that's why it just triggers internal server error. For future development, it may be done a lot more descriptive what's happening, but also it should be visible here as well. Yes, in fact, if you can see here, starting Node.js, because it has got changes, this is NodeMon, just trigger all these updates, changes, must provide a proper. So this is the error because the test doesn't exist anymore. So this is the base application explained. What is so far. The other two elements are the backend for the Doc2KG is not much different, except that it's not a proxy server, it is just a normal Express server. And let's see, and what I have done is for testing actually have put this time delay of 2 seconds that you can notice here that I just, the reason to put it is I wanted to see whether the front end will have the status of waiting for response mitigated properly, and being, I will show you on the front end when it comes to the front end application. Okay, so what I wanted to do is just go to the front end. If you see here this loading, it stays for about 2 seconds, and after that it gets ready for development. So let me just finish one more time. So you can see this loading status, 2 seconds, and then it gets the result. One other thing that I want also to demonstrate is that error capturing. As you can see, the backend server captures any errors and reports them with 500 code. Let's just show a new error here, just for the sake of the demonstration. So if we save this, and now you can say that actually it already node-mon has captured it, restarted service, blah blah blah, and everything oops, there is an internal server error. It is because I'm not capturing different types of errors. You just say, oops, something doesn't work, but at least it works when an error comes. Just go through here, restart this. And as you can see that I got the 500 error being responded from here. Actually, it is here triggered the error, but here is where I capture it to report it back to the front end. Okay, I don't need this anymore. What I wanted to have a look as well, if go back to the containers, and if we go to the backend container, which is this one, if we go to the logs, simulated error for testing. So if you can see it here, it also node-mon has captured the changes in the code, and a lot of interesting things are happening. So this is how it works for the time being. Let's go back to this code and get rid of this throw error statement. So now everything should go back. It shows this interim because it probably hasn't restarted the server yet fully, but now it should go back to the normal, because it takes some seconds, milliseconds for the backend server to restart backend services, and the front end is probably quicker when it's trying to get a response, whatever is the reason. But yeah, it's now up and running. What else? And I got the front end application. So the front end application is a little bit more complex in terms of that I'm using Vite. The reason to choose Vite and to prefer Vite is because my target is to have a single page applications. So my target is effectively to have 3 separate single page applications which are coordinated with the proxy or relate by the proxy to which one to use. And as I mentioned, the document to knowledge is very much an input, driving the information from the documentation into the knowledge base. The IFC to knowledge graph is doing the same with the models, but the actual application from the end user will be the rack application. So in this case, if we want to show to the end user the application, we could just deliver the rack application. The others are for input and rather administrative functions than the end user application. But this will become more and more visible and more and more prominent when the development goes on. However, in summary, I prefer to use Vite. One note about Vite is that I need to create a base for each of the applications. So this aligns with the route, and this is how the proxy is synchronized to use those naming conventions or those names for the routes. Also, the other thing that I want to point your attention is to add this watch use polling true, and the other one HMA protocol, the web socket. It is in order to enable the thing to work in Windows stroke Docker setup that I'm demonstrating at the moment. Other than that, in terms of using White, I suppose that it is all very standard vanilla setup. And I will move now a little bit to the coding. So yes, for this application, I have choose to use Chakra as a graphic user interface. And in fact, let me actually open the package JSON so I can show you which packages I'm using. I mentioned Chakra for the user interface. It is React, TypeScript, and using some things. So these are my dependencies at the moment, but I'm sure they will start to grow once I'm going to documentation. I will need a library for PDF files, etc. So there will be some more to come, and there are some development dependencies. Yeah, you can say that I'm using Light for this development, and I think that this will be the main points that I wanted to highlight for the setup. In terms of the source code, it is again, yes, it is in a standard SRC folder, and I think there is nothing special in the application. Yes, another library that I decided to use is that I'm using Tanstack for state management. I have had a look on some possibilities, but I think that this is the one that pretty much matches the best my intent, what I want to achieve. So I'm staying with it at the moment. Let me just see. Yes, I have it here in the dependencies. Apparently, it must be there, but just missed to mention it when I was reviewing the package JSON. And yeah, the rest looks a little bit too big for me to be the main file. We'll need to break it down into the future when making a little bit more complex, but for testing purposes, this is what I got. And let's start from the bottom with the data access. As you can see, the fetch point is actually the backend pipeline, and this is what should happen is the proxy should relay the request to the backend service, get whatever is the response. It is a boilerplate code from the Transtack website, but I'm sure that when the applications start to grow, this sort of request will become more complicated, more complex. Okay, so I will not go through details about using Chakra and the coding, but I found it very, very useful and very easy to use with being able to create layouts and use different elements. So if you prefer using another libraries at this stage, it should be just remove the Chakra, put another library, whatever, and not too much of a code at the moment in the application. So this is the code. And let's make another little demonstration that if changing the this code. So if I got this heading, which is document stack, I say hello and save it. So now White should monitor and I should see the hello here, re-rendering the application. And same if I, so this is what I have mentioned through the proxy to enable the WebSockets. All this happened because the WebSocket proxy has been enabled and allows White to communicate with the backend and the front end. Right. As I mentioned, this is only the first pipeline. Let me just spin all the pipelines now. And with this, I will complete my demonstration. So I will do this down. So this will ensure that everything is clean, and I will restart this time all the containers. Sorry, because yeah, I think this is also useful when working on one of the pipeline to be able to run just one of them to avoid overloading the system with too much containers running. So the next one is compose dev. So I have doc to kg ifc to kg.yaml, and I got one more file which is compose dot. It is a development compose file, so it will be .dev dash rag dot yaml. Want up command and I want -d just to be as a background. And what it says that the system cannot find a specific file which is dot. Okay, let me have a look in the other YAML. Okay, probably misspelled something. Compose. Okay. So there are some more containers to start. Actually delete this, but yeah, if you can see here, one thing to note here is I think that the CPU is a bit busier now because it's running more containers. Hopefully all of them are starting, but the main consumer is the Node Neo4j database. So anyway, it will be needed to use, but if you can see each node, okay, on the back end, I'm using Node Alpine. On the front end, I'm using the normal node containers. And if you can see, there is a slight difference about how much loading each of them are doing. It's running well on, let's say, on a good laptop or on a good desktop computer. Yeah, just try it, and you will see if there are any performance concerns. But think that yeah, with running all the containers, Docker is doing quite a good job. So what I wanted to check now is whether all of those links will be working. So let's do one refresher. See, so the reason yeah this is delaying and it is expected is because White is when I do the first request, White is generating, creating all the assets, etc. So it's doing some job for a few seconds. So it should come to this. The other pipelines, it should be the same effectively. I haven't created any special code as yet, but just to make sure that it is all the containers are running. So these two are running. This one, the IFC to knowledge graph containers. Okay, they are working as well. Going back to the document knowledge graph stack, it's coming quicker the second time, so it's already White has started, has created everything, so it's up and running if you are navigating after that. And as I said, when it comes to deployment to production, this will be a separate topic, but I'm looking to be a static asset that can be probably the best way to deploy them for production is using something like S3, AWS 3 bucket. So it shouldn't be a big issue for to create the production assets when using White and a single page application. With this, I have completed my live demonstration, and my last slide is just a few final notes. So the vision that I want to do an implementation and to get something working is articulated on nedev.digital, which is my blog posts. The source code is on GitHub in VeriBIM-KG under my name, Vasil Nedev. And if you are interested, or if anybody wants to contact me, the best way will be if you use my contact details on LinkedIn, and it's easy, straightforward to find me. My profile there is just under my name, Vasil Nedev. So thank you very much for your attention, and I will stop my presentation now. I will stop sharing and we'll stop the recording. Thank you very much once again for your attention, and please check out the documentation if you are interested in. Share your views. If you find something that you really think is not correct, or there is a better way, or you have a different view, I will be very pleased to hear from you, or just give a simple thumbs up in the social media just to show your support in terms of what I'm trying to do, what I try to achieve. So thank you once again.